We're now going to solve problem 2 given in the 2017 spring exam. So here we're given the first derivative of f of x, both the equation and the graph. We're also told that the function intersects the x-axis at 3 points. And based on that, we're going to sketch f of x. Okay, here we are given sufficiently information to simply make a simple graph. Let's see, so we have x here, we have y, and it intersects the x-axis at x equals 0. We have -1 and we have 1. Okay, if we look at this interval here up to minus 0.5, we see that the derivative is positive, so we need to go up. So it needs to go up something like this, from minus 0.5 to plus 0.5. The derivative is negative, so the graph needs to go down. And then we have a positive graph from 0.5 to 1. It needs to go up again. So we have maximum minimum points where the derivative is 0. So this has to be the maximum minimum points. All that is needed is a simple sketch showing the shape and the correct intersections of the x-axis. We don't really know where we are here at the top and bottom points, but there are a few things we need to make sure. Make sure you name your axis and your graph. And also, in this interval, we have a positive f of x, so the graph needs to go up. In this area, the derivative is negative, and then it is positive again. We don't have to limit the graph. Okay, so this is basically what we need to get full points in A. In B, we want to determine the expression for f of x. Okay, well, f of x has to equal the integral of f derivative of x. Because if we derive f of x, we get the derivative, and if we integrate the derivative, we go back. Okay, so we simply need to insert the derivative that we were given, and that's x third minus x, and then we have this integration constant. The thing is that we can determine this integration constant using one of the points. So we could use, for example, f of 0, which should be 0 since the graph intersects at x equals 0. And then we get f of 0 equal to c, according to the equation here. So c has to equal 0. And thereby we get f of x equals to x to the third minus x. Of course, you could also have used the fact that f of 1 equals 0, which would basically give us 1 to the third minus 1 plus c, which is also c. And that should also be 0. So Which of these 3 points, minus 1, 1, or 0, we use doesn't really matter. We get the same expression for f of x. In C, we want to calculate the local maximum or minimum points. And the local maximum and minimum points are found where the derivative of x equals 0. So those are found where 3x squared minus 1 equals 0. So we have x squared equal to 1/3. Or x squared equal to 1 over square root of 3. And here we need to remember the plus minus sign. So it's not totally 0.5, which I read from the graph, but it's more like it's plus minus 0.577. This is the x. So this is our x value. So if you go back to our graph, this is where we have our maximum minimum points. Or here, which I read as 0.5, but that's not accurate. Okay. But now we only have the x value. So we need to figure out what's the y values of those. So we start with one of them. Let's say we get x equals to 1 over square root of 3. So if we put that into our function, we use whatever we had in for the function. We had f of x equal to x to the third minus x. If you have that wrong in B, you will not get another mistake here. I'll simply use whatever you got in B when I correct. Okay, so we insert 1 over square root of 3, and you can do the math on this, and you will get 1 over 3 square root 3 minus 1 over square root 3. We can expand the last one like this. So we will get minus 2 over 3 square root 3. It doesn't really look good when you have square root underneath, but okay. So the point x, y equals to 1 over square root 3, 2 over 3 square root 3. That's local maximum. It looks better though if you have it like this. If you multiply with square root of 3. Or you could simply use decimals. So all of these would be full points. We also know that this is the local maximum. And that we know from the graph. Or from what we're given in the text, because f derivative of x is larger on the upper side and then smaller, or positive and negative. So we need to go up and down. And then we test the other point. Like this. And we get minus because we have minus times minus times minus here. And then we get a plus since it's minus times minus. We expand the last one. And we get 2 over 3 square root of 3. So we now have xy equals to minus 1 over 3 square root of 3, 2 over 3 square root of 3. Or as before, you could write it like this, which looks a bit prettier since we don't have a square root underneath. Or simply with decimals. You choose. And this would be a local minimum. So, in order to get full points, you first need to find the x values and then the y values and conclude whether or not it's a minimum or a maximum. Calculate any inflection points of f of x. So inflection points are found where f double derivative of x, or second derivative, equals 0. So if we have the first derivative equal to 3x squared minus 1, the double derivative would be 3 times 2x minus 0, so it's 6x. So if we set f second derivative to 0, then 6x has to be 0, so x has to be 0. And we need the inflection point, so we need f of x, where x is 0, and we're already given that. You could calculate it again if you want. So xy equals to 0, 0 is an inflection point. Concave down. The graph is concave down when the double derivative, concave down means this, when the double derivative is less than 0, which basically means that x needs to be less than 0, and concave up when the double derivative, second derivative, is larger than 0, which means that x has to be larger than 0. And you see that you have this situation here. Here it's concave down, and then it's concave up. So that's good. Okay, now we're given a continuous random variable x, and we're given the distribution as a function. And that function is named a probability density function. And we are asked to plot the function from x equals to minus 4 to x equals 4. Okay, so below minus pi and above pi, it is 0. And in between, we have this strange thing here. So, I used my calculator to generate a table like this. I did it before we started the video because that takes a little bit of time. But it is simply to put in all the x values into the function here and get the y value, or the g of x. Remember those to set your calculator to radians, because if it's in degree, you will get the wrong answers. The reason why you can see that you should use radians is that there's a pi several places. If it has been degrees, you should put it in. You would get degrees in the axis. Anyway, now we need to try to plot it. So on the x-axis, I need to have numbers from, well, this is easier if you don't have a blank sheet, but anyway, I'll try. I have from -4 to 4. And on the y-axis, I see that I don't have any negative values, and my maximum would be 0.3 something. So I simply make an axis that fits those values. And again, please remember to name your axis. Okay, so I'll just put it in red here so you can see it. So from up to minus pi here, the value is 0. And I put this to indicate that minus pi is included. So this is minus pi. And also on the other side, from pi, including pi, we get 0. If you have -3, we're a little bit above. -2, we're almost up to 0.1. -1 is 2.4, somewhere here. 0, we get up to 0.31, somewhere here. And we have the same values on the positive side. Okay, like this. So if we connect the dots, trying to make a more or less smooth curve, we get something like this. So in the middle here, the minus pi to pi is not included, but we can get very, very close. So that would be our graph. Remember also to name your graph. In this case, we've plotted g of x. Test if g of x is continuous. Okay, so the thing is that a 0, that's continuous, and the other 0 is continuous, and this one is continuous. So what we need to make sure is that in the transition, we don't need to lift our pen when we plot the function. So here, x equal minus pi is included, but here we only approaches x equals minus pi. So we include minus pi when we get from the negative side, but we only get very, very close when we get from the other side. So what we need to make sure in order for the graph to be continuous is that when we approaches x equals to minus pi, it is equal to g of pi. And the same thing on the other side. Oh, sorry, there should be a minus sign there. Okay, so when we approach minus pi, it has to equal g of minus pi, and when we approach pi, it needs to equal the function of g of pi. Okay, let's check. Lim x goes towards minus pi g of x. That would be lim x goes towards minus pi. We could also put a little plus sign here to indicate that we're going from this side, values larger than. And on the other side, we're going from lesser values. Okay, and that has to, we have to insert this function thing. And we insert minus pi. This one becomes 1. So we get 0. And the other side, lim x approaches pi from the lesser values, and we insert the part of g of x that works in that area. And then we exchange x for pi, and we get 0. So this is what we need, and this is what we get. So because of this, g of x is continuous. In G, we need to check whether g of x satisfies the condition for being a valid probability density function. So there are 2 conditions. The first one is that a PDF is never negative. And the second one is that the area under the graph is 1. So we check. So the first one, g of x is always larger or equal to 0. If we go back to our function, we see that we have this threefold definition. So it's okay when it's less than minus pi or larger than pi, because then we get 0, which is not negative. Now in the middle here, we see that cosine of x is always larger or equal to minus pi. That's the smallest value we can get. So 1 plus cosine of x would then be larger or equal to 0. Because if we have the minimum value minus 1 and we add 1, we get 0. So this one is okay. The second, the area under the graph equals to 1, so we need to check the integral, because that's how we find the area. Okay, we see that if x is larger than pi or less than minus pi, we get 0. So this would be the integral we can restrict a bit. Okay, and then we need to calculate that. So we need to insert the expression like this. Let's have a new line here. Hopefully we'll get 1 out of this. Okay, let's include, put 1 over 2 pi in front. That will make it a little bit easier. So you can do it like this. And then we'll find the integrate stuff. X plus sinus x, and please make sure that our signs are okay, so it's plus sinus. And we insert our limits here. So we get 1 over 2 pi. We get pi plus sinus pi minus minus pi plus sinus minus pi. So here the pi we keep, the sinus pi equals 0. Here we have a minus and a minus, so we get plus pi, and the sinus minus pi equals also 0. So that would be pi plus pi, so we get 1 here. So this one is also okay. So this makes the conclusion that g of x is a valid PDF, short for probability density function. Calculate the probability of x having a value between minus pi half and pi half. Okay, so the probability that x lies between these two values, that would be, so this is our graph, so that would be equal to this area here. I'm just naming my graph and my axes. Okay, so the probability that something will happen equals to 1. That's why the total area is 1. But if you want a restricted part of it, you need to find the area in that area. So that would be if we insert our function in that area. I'll put the constant in front again. And we'll find the integration thing. You can use the formula sheet if you don't remember. And we insert the, here's next, the upper limit minus the lower limit. And please make sure you're not confused by all these the signs. Okay. So now we have 1 over 2 pi. We have pi half. And then we have sinus to minus pi half. And if you look at the graph, you'll see that that would be, if we have the sinus thing here, it will go something like this. So we have pi here, we have pi half here, so we will have 1. Like that. And then we have minus pi half. So we have a minus and a minus would be give us plus. And this one would be minus 1 with a minus and plus. That would be a plus 1. So basically in the end here, we will have, let's see, 1 over 2 pi, and we get a pi plus a 2. Yeah, we could put that like this if we want, or keep it like this, you decide. So that would be our probability. Okay, next one in I. The total annual costs in 1,000 NOK for ordering and keeping a certain product in stock is expressed like we're given this function h, where x is the amount of products we purchase in each order, the order quantity. So we want to calculate the order quantity x that minimizes the total annual cost. So if you want it to be minimized, we need to find the derivative. So the first derivative needs to be 0 in order for it to be minimum or maximum. Okay, so h of derivative of x equals, if you find the derivative, this would be 0. This would be minus 64 over x squared plus a half x squared. No, now I found the integral. Sorry. Plus 1. Okay, and that has to equal 0. So, I can put 1 to the other side. I can multiply with x squared, and I can multiply with minus 1, and then I get plus minus 8. Well, a negative order doesn't make sense. So only positive quantities make sense. So x has to equal 8. Calculate the order quantity x that minimizes the total annual cost. The thing is that I don't know if this is a minimum or a maximum at this point. So I want to use the second derivative test. Because I need to figure out if it's a minimum or maximum. So my second derivative, if I find the derivative of this expression here, I get minus 64 times minus 2 and then I need to reduce my x once more. You see here, if you find the derivative of x to the nth, you get n x n minus 1. Well, in our case, we have 1 over x squared, which is x to the minus 2. So our n equals minus 2. So that would be minus 2 x to the minus 2 minus 1, or x minus 3, which is 1 over x to the third. So this would be just some explanation for you. Where were we? Yeah, we tried to derive this one. So this one would be 0, and then we have this other term here. So this would be 2 times 64 would be 128 over x to the third. And that is positive when x is larger than 0. So this means that x equals 8 is a minimum, because when it's larger than 0, the graph is concave up and we get a minimum. And that's it.